Welcome to the University of Michigan Dentistry Podcast Series, promoting oral health care worldwide.
A number of dental restorations are used as bridge retainers, and the same principles of resistance and retention form, of convenience form, outline form, and extension for prevention apply. But because when used as a bridge retainer, there is a pontic attached to the restoration, additional stresses fall upon the restoration when it's used as a bridge retainer. In order to understand the problems involved, it's necessary to examine the stresses which fall on the teeth and see just how these transmit themselves to a bridge retainer. If we take a look at the diagram here, we can see how when the mandible opens and closes, as it is doing here, and the teeth come together and meet in centric occlusion, stresses are brought to bear on the occlusal surface of all of these teeth. If we now move to the larger diagram, we can examine the exact nature of those stresses as they affect individual teeth. Here we have a maxillary molar and two bicuspids, and here a mandibular molar and two bicuspids. You know from your studies of anatomy that each of these teeth is supported in a periodontal membrane around here, which allows some movement of that tooth. And if the tooth were pushed on the distal here, it would move mesially. If we pushed it on the mesial here, it would move distally. If we pushed it on the buccal, it would move to the lingual. And correspondingly, if we pushed it on the lingual, it would move towards the buccal. These movements take place about a fulcrum, which is somewhere here, about the junction of the apical and middle thirds of the root, so that each one of these teeth is capable of individual movement in its own socket in all directions. Now, when the teeth come into occlusion, as we see in this diagram here, the movement which takes place as they come into occlusion is demonstrated on this model here, with each tooth moving mesially. It moves mesially because of the inclination of all of the roots of the maxilla in this direction and the mandible in this direction. So that as they come together, a forward component is developed which tends to push the teeth forwards in their socket. It's this anterior component of force, of course, which is responsible for maintaining tight contacts for the mesial drift of the teeth. And also the reason why this molar would tilt forward if this tooth were extracted here. So with that recognition of the types of movement that take place in the teeth, let's see what happens if this tooth was missing and we placed a retainer on this one and put a fixed bridge between these two teeth here. We would lock together two teeth which had been previously able to move independently. This is the mandibular molar that we were looking at, in which a bridge retainer preparation has been cut here. And this represents the bridge running along here to another retainer on the bicuspid here, which for simplicity is not shown in this diagram. Now that these two teeth are linked together by the bridge across here, the whole thing has to accept stress and respond to it as a unit. And any weak link within this structure here is liable to fracture and to dislodge the bridge. Let's see what happens when the anterior component of force operates on this particular bridge, as you see here. The anterior component causing the forward movement puts stress on the cement lute around this situation here, and in this particular retainer, which has a fairly short clinical crown and marked taper of the distal and mesial surfaces here, this tooth can move out of the gold restoration here, pivoting about this point as the tooth rotates on its fulcrum down here. I think if we can just do that movement over again, you will see, if you look at the cement lute around here, that it is being subjected mainly to tensile and shear forces. And because cement has a very poor tensile and shear strength, it will not stand up to this type of stress for long. It will fragment and break. And so this retainer will come loose on this particular preparation. So you see here a situation where a short clinical crown with tapered proximal surfaces on the distal and the mesial, such that it allows the mechanical rotation of the tooth out of the retainer will result in the failure of this particular bridge retainer on a point of retention. Here is a similar bridge to the last one with a molar tooth here and the bicuspid here not shown in the diagram. But in this situation the preparation is a little different, as you'll recognize. The crown of the preparation here is longer and the distal and mesial surfaces are not so tapered as was previously the situation. Now let's see what the effect of the anterior component of force is on this situation. As the teeth come into occlusion and the anterior component of force exerts itself, you'll see that this tooth, in order to rotate out of the retainer there about this point, that this part of the tooth preparation would have to move forward through the gold here, which it cannot do. You'll see also that the cement down here is now subjected to compressive forces and not to tension or shear forces, and it has a very high compressive strength, so it will withstand this type of force over long periods of time and not fragment. And such a retainer will maintain its position in relationship to the retainer satisfactorily, and it is this quality of a retainer which is most important to recognize the adequate length here and the absence of marked taper on mesial and distal surfaces here, so that the thing has a mechanical design in which attempted movement of this subjects the cement lute to compressive forces and not to tensile stresses. Just to review the points which we've been discussing, on the left-hand side of the screen is the preparation with the short clinical crown and tapered proximal surfaces, and on the right-hand side the preparation with the long clinical crown and the absence of marked taper on the proximal surfaces. You've seen how when the anterior component of force works on these teeth that the short tapered crown creates a situation where displacement is possible, whereas the one with the long clinical crown does not permit this to operate. In this particular situation, we might be looking at a cross-section through a complete crown preparation. Exactly the same thing would apply, of course, to the three-quarter crown, to an MOD protective cusp. It's important, therefore, in making these preparations to watch these particular points. It sometimes happens in a clinical case that because of a short clinical crown and possibly a tilted tooth, it becomes impossible to do a preparation other than the type we see here on the left-hand side of the screen, in which situation additional steps must be taken to achieve retention by putting pins or grooves in critical parts of the preparation, and these we'll look at in greater detail later on. This list shows the restorations most frequently used as bridge retainers. The three-quarter crown is used in both anterior and posterior teeth. The veneer crown, which is a complete crown with an aesthetic facing either in resin or porcelain, is used on anterior and posterior teeth. The core post crown, which is a two-part crown consisting of a core which used on a non-vital tooth goes into the root canal, and then over this any type of crown, a veneer crown or a cast crown. The core post crown is used on anterior and posterior teeth which are non-vital. The cast crown is an all-gold complete crown, which of course is only used on posterior teeth where the aesthetics are not critical. The amalgam core crown is used on vital teeth where a great deal of tissue is missing and a core is built up in amalgam which is retained in position with pins, and is used mainly on posterior teeth. The MOD inlay is a good bridge retainer if correctly designed and is used of course on posterior teeth only. The pin ledge, a very good restoration, a very conservative restoration used on anterior teeth, and to some degree is largely replacing the three-quarter crown on anterior teeth. As we have seen, the three-quarter crown retainer is used on both anterior and posterior teeth. At the present time it's more extensively used on posterior teeth. So let's have a look at some examples of three-quarter crowns on bicuspids and molar teeth. Here is an example of the three-quarter crown on a bicuspid tooth. It's the most conservative type of three-quarter crown, one in which the retention is gained merely by means of a groove on the proximal surfaces running across the occlusal and down the other side. You can see how this three-quarter crown type preparation gets its name from covering essentially three-quarters of the crown of the tooth. And that the labial surface, which is not prepared at all, is left in its original state, and so no change in aesthetics is produced in that regard. As we have seen earlier in the diagram, it's the length of these grooves on either side and the degree of taper, the minimum degree of taper of these, that gives the essential strength to this type of preparation. You can see that the whole of the occlusal surface is covered and is protected right up to the margin of the buccal cusp along here. This then is the most conservative type of three-quarter crown with groove retention on the proximal and across the occlusal. It has slices on both the mesial and distal surfaces and is excellent for use on a tooth which has no previous caries or restoration. A somewhat more extensive preparation than that one we were just looking at is one here using the box type of retention and an occlusal keyway running across the occlusal surface, as you see here. You can see that this creates a greater bulk of gold, and here gives you a stronger and more rigid restoration. It is one that's typically used perhaps when there's already a previous restoration in the tooth, an MOD amalgam or an inlay maybe, in which this type of box and occlusal keyway has already been cut. This particular preparation shows a combination of both the slice on this surface here and of the box type of finish on the mesial here. Now this is a maxillary bicuspid tooth, and the box preparation is done on the mesial because it gives greater control over the extent of gold showing on the mesial surface here. I think you can see, comparing the position of the boundary on the buccal surface there with the one on the distal where the slice is here, that it's considerably more conservative in extension on the mesial than it is on the distal. Where you do a slice, it's necessary, of course, to go this far out in order to get removal of the external undercuts of the tooth, which is so essential. Another thing which is done in this particular preparation, I think you can see, is that the degree of occlusal protection of the buccal cusp varies. It's maximum here on the distal of the tooth. It's minimal here on the mesial surface. So that, again, this serves to reduce the amount of gold that might be seen in the mouth. So this then is the second type of three-quarter crown on a bicuspid tooth. Here is another variation of the same type of preparation in which a ledge is cut around the lingual cusp in this situation, just to give added retention and added protection to that particular situation. But the rest of this preparation is essentially the same as the previous one. You can see the combination of the slice on the distal surface here, of the greater occlusal protection of the distal slope of the buccal cusp, and then on the mesial surface here the use of the box type of preparation to reduce the extension into the proximal area there and reduce the amount of gold which is exposed. This characteristic is projected onto the molar tooth and gives a preparation such as you see here. This is the box type of preparation on the molar tooth. And again, this has a slice on the distal surface and has the box type preparation on the mesial surface here, again, in order to reduce the amount of gold which is shown here. You can see the amount of occlusal protection here, again, is kept minimal on the mesial cusp and becomes a little bit more extensive on the distal. And obviously this can be modified according to the particular tooth and the strength of the remaining tooth substance. You can make it greater or lesser than this according to the particular situation. So that then is the three-quarter crown of the box type on a molar tooth. Another modification of the three-quarter crown is the mesial three-quarter crown, or sometimes called the mesial half crown, and you see an illustration of this preparation here. It's usually done on a molar tooth, usually a mandibular molar tooth, and it's a particularly good preparation where for one reason or another you do not want to be involved in the distal surface of the tooth in doing the preparation. If there's no previous restoration, no caries here, and possibly a difficult contact relation on the distal or a difficult soft tissue relation, or a problem of an external undercut in relation to the adjacent tooth. All of these situations point to avoiding preparing that surface. And so the three-quarter crown gains its retention from grooves which this time are on the buccal and on the lingual surface of the tooth here. It has an occlusal keyway running through, as you see here, just rather like a class 1 inlay. And you can see that the mesial cusps on the buccal and the lingual are covered and protected by the restoration. However, in this particular preparation, the distal cusps on the lingual and the buccal are not protected. They can be if the situation requires it. The preparation can be extended to give protection over those distal cusps also. Let's take a look now at the situation of the three-quarter crown on anterior teeth. And we have said that it's not so extensively used on anterior teeth as was the case in the past. It's been replaced to a large extent by the pin ledge restoration, which is easy to do technically and has the advantage usually of leading to better aesthetics. The three-quarter crown on the anterior tooth has the same retention characteristics as on the posterior teeth. It has these proximal grooves on either side, and it's on the length of these, of course, and the degree of taper that the retention is secured in this particular type of retainer. There is a groove which joins these across the occlusal here, and that gives some retention to the preparation. It also gives adequate strength to it, of course, as it runs across from proximal to proximal. Now you can see that in order to get the necessary retention, these grooves have to be of adequate length, they have to be on the proximal surface, and they do to some degree determine the extent of the slice that must be made. And on many situations, having to put a groove here will lead to bringing the gold further forward in this region than you would really like from an aesthetic point of view. And this is one of the great advantages of the pin ledge preparation. As you know, of course, it gets its retention from pins on the lingual surface, not on the proximal, and you have more or less complete control of the proximal design. And if you want, you can stop the preparation much further back in the proximal area than you would with a three-quarter crown. So for this reason, the three-quarter crown is being used less and less in anterior teeth. When we use such a three-quarter crown for bridge preparation, we usually cut a little recess in here, as you have done, and place a pin in there to give added retention. That type of modification is seen here on a three-quarter crown on a maxillary incisor tooth, where a pinhole has been cut in a little recess at the cingulum area. This is a modification of the three-quarter crown used on a central incisor, particularly where there's a thin incisal edge and there's not enough room to cut a groove across here. This one, as you can see, has only proximal grooves on the mesial and distal. And in this case, it's certainly desirable to have added retention here. But by and large, in bridge work, we would always place a cingulum pin. If it's a single restoration, it isn't necessary, of course, to do that. Here's another three-quarter crown on a maxillary incisor of the more standard type, with both proximal grooves and an incisal groove running across. Notice the protection of the incisal edge here, which is kept to minimal so as not to interfere with the labial aesthetics of that thing. Notice the necessary thickness of tooth left in here so that the cement lute on this surface will not show through any translucent incisal edge. Here again, a recess and a pin will be cut here where this to be used as a bridge retainer. The three-quarter crown varies a little bit according to the shape and character of the particular tooth. Here is one done on a mandibular incisor, which creates just a slightly different picture in the finished preparation. This particular one has grooves cut a little more extensively and made so as to be sort of retentive in themselves. They're rather key-like, as I think you can see in that cross-section, so that they're additionally retentive from that point of view. But here again, this type of preparation would probably be replaced by a pin ledge in current practice. You should, however, be familiar with these because you may come across bridges that have been in position for some years in which this type of preparation has been used, and you find yourself having to work with it and to repair it. Another modification of the standard three-quarter crown preparation is shown here, in which a box replaces one of the proximal grooves. This is usually done in cases perhaps where there's been a previous restoration here, perhaps a composite or a silicate material which has taken away some amount of tooth substance where the groove would normally be cut. And obviously the exact size and shape of the box will vary according to that particular lesion, but this is quite an acceptable way of dealing with it. Other additional retention that can be placed in three-quarter crowns are these little grooves placed almost anywhere around this lingual surface, wherever they may be. If you're short of retention, if these grooves are not as long as you'd like, you can get additional retention from cutting little lugs or grooves into the surface, as you see in that particular one. Here is a three-quarter crown on a cuspid tooth in which a modification of the box type has been made on both proximals. This might be done where there are mesial and distal silicates which have taken away that tooth substance. It's a modification that's also made if you're going to be used in a precision attachment type of connector here, which requires a fair amount of room for the placement of the attachment in the retainer itself. So that would be another situation where this type of modification might be made. That completes the review of the several types of anterior and posterior three-quarter crown retainers. And the next type of retainer, which we should go on to take a look at, is the veneer crown retainer, of which you see a model here. The veneer crown retainer is used, of course, on both anterior and posterior teeth, wherever aesthetics is critical. And the particular model we have here is of a preparation on an anterior tooth, a maxillary incisor tooth. The complete crown preparation, which this is, of course, is one which gives maximum retention. As you can see, the areas involved in retention are at a maximum here. All of the axial surfaces of the preparation participate in retention and anti-torquing activity. The preparation on an anterior tooth is made with a labial shoulder, such as you see here, which fades away in the proximal surfaces to either a shoulderless or a chamfer finish running around the lingual surface here. As you know, in the finished preparation, the lingual surface is generally gold, and the labial surface either porcelain or resin, according to the type of facing which is utilized. It's important in these preparations, as in all other situations, to keep a minimum taper to the axial wall, just sufficient for convenience in taking impressions and so on, but the minimum taper gives the greatest retention. Additional retention can be secured by placing a recess and a pin on the cingulum surface, as you see has been done here. And in any case where the crown is perhaps on the short side, or there is some doubt as to the retentive quality and it's being used as a bridge retainer, it is good practice to place a cingulum recess and a pin to ensure adequate retention. The next type, or the next modification of the complete crown, which we should perhaps take a look at, is the cast crown, which is used on posterior teeth. This is a complete crown preparation in which there is no aesthetic facing. The whole crown surface is in gold, and it is, of course, only used usually in the mandibular molar teeth, occasionally in the maxillary molar teeth. And you see such a preparation here on a mandibular molar tooth, which this is the buccal surface at which you're looking, and the proximal surface and the lingual surface. And here again you've got the maximum retention, all of the axial surfaces being contributing towards the retention of this type of preparation. Where this may have perhaps excess taper, which it doesn't in this one, or where the clinical crown is very short, as is sometimes the case in a mandibular molar tooth, additional retention can be obtained by placing boxes or grooves on the proximal surfaces, on the buccal or lingual, or on the mesial or distal, or in all of these situations. These create internally the near parallel walls which may be missing on the axial surfaces of the preparation itself. So the cast crown, then, a sort of non-aesthetic complete crown used in posterior teeth, is another retainer which gives maximum retention as a bridge retainer. The MOD inlay is a useful retainer in teeth where previous restorations may have been present. And you see here two examples of MOD inlay restorations on bicuspid teeth. Take this one, for example. Possibly a bicuspid tooth in the mouth might already have an MOD inlay or an MOD amalgam in position. And perhaps the most conservative way of converting it into a bridge retainer is to utilize essentially that preparation and just to give occlusal protection to the cusps, rather than perhaps, say, going to a three-quarter crown and cutting away more of the lingual cusp, which is already perhaps somewhat cut away by the previous preparation. And you see here a typical MOD preparation in a bicuspid tooth with slices on both mesial and distal surfaces, and the box type of retention going across the occlusal key here with occlusal protection of both buccal and lingual cusps. Another modification of that situation is seen here and is often used in the maxillary first bicuspid. This preparation has the box type of preparation on the mesial surface here, and on the distal surface has the slice preparation with box retention built into it, and then an occlusal keyway running across. The same control of occlusal protection can be done here as was done in the three-quarter crown, where you give heavier protection to the distal slope of the tooth than to the mesial slope of the tooth. So in a way this is almost like one of the three-quarter crowns that we looked at, except that the lingual surface of the lingual cusp is not cut away and protected. And this then is something that you would use in a tooth that had previous restorations, an MO, a DO, or an MOD amalgam or inlay. This would be the means of converting it to a bridge retainer with minimum extra cutting of the tooth substance. It's possible in these situations, if necessary, of course, to place additional retention by means of pins, and these can be placed down in the cervical, perhaps one on either side here, or they can be placed in the tips of the buccal cusp if due regard is given to the position of the pulp chamber, and these will give additional retention in this type of situation. The MOD inlay, then, a useful type of bridge retainer in cases where previous restorations are present in teeth. Can be used, of course, on bicuspids, as shown here, or also on molar teeth, either in the maxilla or in the mandible. Although the pin ledge retainer is described in the dental literature back in the 1880s, it was not until the 1950s, with the advent of rubber-based impression materials, that it became extensively used. And since that time, it has been increasingly used, and as we have already said, tending to displace the use of the three-quarter crown on anterior teeth. Two typical pin ledge retainers are shown on these models here. On the one on the right-hand side of the screen, this one here is the so-called bilateral pin ledge, in which there is a slice on either side of the maxillary incisor, which this is, with three pins giving retention on the lingual surface. And over here on the left-hand side of the screen is the other variation of this, the unilateral pin ledge, in which only one side of the tooth is sliced. This has the advantage that it's not necessary to get involved in the contact situation on this side, and essentially the same amount of retention is gained by the three pins on the lingual surface here. The retention in these cases, as we have said, is gained by three pins on the lingual placed in these recesses on the either end of the incisal ledge here and in the cingulum ledge down in this situation, and these give the necessary retention, so that the position of the proximal slice here can be modified, can be controlled according to aesthetics, in contrast to the three-quarter crown, where you remember it had to be extended to include the area of the proximal groove. This same basic preparation can be used on many teeth with a number of different variations. When it's done, for example, on a maxillary cuspid tooth or a mandibular cuspid tooth, then the incisal edge is modified a little to conserve the tooth substance, and instead of running straight across has this rooftop situation that you see in this particular model here. Again with three pins, one at either end of there and one on the cingulum ledge. It's sometimes convenient to modify the position of the cingulum pin, and in this model here we can see that the cingulum pin has been offset to one side. Here you see it in the central position. On this model here, it's offset to one side to avoid close proximity to the pulp in that particular situation. The pin ledge preparation can be used on mandibular incisors with equal facility, and leads to preparations of this type, which you see here. Here's a bilateral pin ledge preparation on a mandibular incisor. Slightly different shape because of the slightly different shape of the mandibular incisor. The degree of protection of the incisal here can be modified from this one, which is minimal, to one in which it comes as far over the incisal as you may wish in any particular case. You can see again here how the proximal extent is something that can be varied without in any way influencing the retention, which is all on the lingual surface in this situation. Modifications can be made to the pin ledge preparation in very similar manner to those for the three-quarter crown, and in cases where perhaps previous restoration has resulted in the loss of tissue here, where normally a pin would be placed, a groove or a box can be cut of varying size according to the particular situation, and retention is gained then by one groove and two pins in this situation. A problem arises in these preparations sometimes in the type of incisor tooth which is very thin, long, thin incisal edge, and the problem then comes of getting an adequate width to the incisal ledge here, and it's necessary to carry that preparation much further down here in order to get an incisal ledge of the necessary width, so it leads to a somewhat different appearing preparation. Again, you still have the pins, one at either end and one in the cingulum here. These have to be placed as far proximally as possible in order to avoid the central pulp tissue here, and additional retention can again be obtained if necessary by cutting little grooves or lugs into the axial surfaces of the lingual part of the tooth, as was done for the three-quarter crown preparation. Again, the extent of this incisal edge here can be varied according to the amount of protection which is required. Here is a pin ledge preparation on a mandibular cuspid tooth, one in which the box type of retention has been placed on the proximal with two pins in this situation. Notice here the groove which runs down the mesial surface of a unilateral pin ledge to give here an adequate bulk of gold, which compares to the bulk of gold in the slice area on this side, so that we get a quadrangle of gold here from which the retentive devices originate, to give rigidity and strength to the preparation. And that, I think, summarizes the main characteristics of the pin ledge retainer, which, as we said, can be used on the maxillary or mandibular incisor teeth, and is replacing the use of the three-quarter crown in those situations in current practice. The core post crown is used as a bridge retainer on non-vital teeth in which the crown, for some reason, is no longer savable. The core post crown can be used on any of the maxillary or mandibular teeth, and the core of the preparation can be covered with any type of complete crown, either a veneer crown where aesthetics are important, or with a complete gold cast crown in posterior regions where aesthetics is not quite so critical. The example which I have on the bench here is of a core post crown on a maxillary central incisor. And this particular one has an acrylic veneer facing to it, and I think as I turn it round you can see the gold part of the backing and the thin line of gold running around the labial cervical aspect of the preparation. Now this is, just as you see it now, a typical veneer crown about which we have already spoken, and you recognize the difference in the preparation when I remove the crown, that here we have, instead of the normal tooth core of the veneer preparation, we have a metal one, which is of course attached to a post going down into the root canal. This post, and this particular one, is a Charlton post. It's a prefabricated one which comes in a number of sizes, and is fitted and adapted to the tooth in question, and the core part that you see is cut to the particular shape of a veneer crown preparation. You'll notice that the shoulders here are a little wider than they are in the preparation on a vital tooth. We're not concerned here with the pulp, so we can have wider shoulders and give ourselves a little more working room in the final preparation. I have another model on which I can demonstrate the actual post itself. So let's take a look at this other model here. Here you see the type of preparation that's made in the mouth for a Charlton post crown. Notice the slot through the preparation there, which prevents the post and the core from turning around, and the sort of ruche shape as the cable surface angle follows the gingival margin, so that it's high interproximally and low on the labial and on the lingual as well. Now the post which goes into this particular preparation is this one here, which comes as a prefabricated post, and this is exactly the shape as you receive it. A drill is supplied which drills a hole down the root canal exactly to match that post, and that is drilled and the post fitted. And if I can just put it in position here, see how the flats on the post slip down into the slot on the top of the preparation, and you'll recognize now that this is the prefabricated shape to the core. It's not been finished or shaped to match the preparation. It will be too wide across the incisal in its present form, and of course in shaping the labial and lingual surfaces you develop the same shape which you've seen in the earlier preparations. The finished core post is then cemented in position and an impression taken, and the usual procedure followed for the construction of a veneer crown. If we turn now to the other model which we looked at the beginning, which shows the finished cemented preparation, and we take a close look at this, you can see, I think, the finished outline. On the left-hand side of the screen is the labial surface, on the right-hand side is the lingual surface, and you can notice now that the incisal is much thinner than it was previously, and I think you can recognize that it now has something of the shape of the regular veneer crown preparation as it's done on a vital tooth. Notice here that, of course, the shoulder is somewhat wider, and this is possible because we're not concerned here with the vital pulp. And by having the shoulder a little wider, we have that much more room in which to develop the gold form and whatever aesthetic facing is going to go over it. So this then is a little smaller in general contour than the same preparation done on a vital tooth. The gold fabrication which is made for this, you see here an proximal view, coming around now to a labial view. Here is the window with the bead retention in it for acrylic resin in this particular case. When we use acrylic resin, we give incisal protection to it, so you can see the incisal layer of gold going across there. Notice the preparation follows the contour of the soft tissues. High interproximally drops down on the lingual surface, rises again to the other interproximal, and drops down on the labial, and the preparation is carried, of course, beneath the gingival margin there, so that the little margin of gold there will be hidden from view. I'm going to take off this gold part of the crown now and place the finished crown on with the acrylic facing in there. And there you see the preparation with the acrylic resin facing. I think you can see the only part of gold you can now see is that thin line along the cervical cable surface angle there, and that, as we have said, is placed just beneath the gingival margin so that that is not exposed. As you turn around, you see the relationship of facing to the gold, and on the interproximal side, which is going to be next to either a pontic or another retainer where you have to have a connector, of course you need to position that gold so that it will receive a connector. So that in this particular situation it would need to be a little further to the labial in order to get a connector in that particular position. this crown was not designed as part of a bridge, but just as a single restoration. In that case, you don't need to bring the gold so far forward. You can see there, I think, that if you wanted to place a connector in this situation here, that you would need to bring that gold a little further to the labial in order to get a soldered joint or a cast connector in that situation. This then is a veneer crown on a core post on a non-vital tooth. Very similar to the regular veneer crown preparation, except for the differences which we have mentioned. The amalgam core crown is usually a bridge retainer on vital teeth, in which most of the crown has been destroyed from one cause or another. It can be used on any of the maxillary or mandibular teeth. It is perhaps most commonly used in the posterior teeth, and especially molars. The example which I have on the bench here shows an amalgam core crown which has been restored with a acrylic veneer crown. And as you see it, looking at it now, you see a labial buccal facing of acrylic resin and a gold occlusal and gold lingual surface. It looks just like any veneer crown. However, if I remove the crown from the tooth, you'll find that underneath, instead of tooth as preparation, we have the preparation in amalgam. Now this large hunk of amalgam is retained in position by pins which go down into the dentine of the vital tooth. And it's a means of building up a central core. You might say, why not make a gold restoration with suitable pins which just goes into the remnants of the tooth? The reason for doing this is largely a matter of convenience and dealing with possible maintenance problems at a later date. If a crown or a bridge which has been cemented on a restoration of this type needs to be removed for any reason, it's a simple matter to remove the crown from the core and leave the core intact. New crowns can be made. Such things can be done to adjust over the years to the recession of gingival margins, exposing the labial cable surface angle of the preparation and spoiling aesthetics of a particular case. So here then is the amalgam core retained with pins going into the vital dentine of a molar tooth. And this one has on it a veneer crown with a resin facing, which you see in that situation. This other model shows an earlier stage in the preparation, and you can see on this one the pins going into a vital molar tooth. And as we take a look at it closer, it looks perhaps a little untidy. The pins are sticking out at all different angles. That's been done deliberately. Now, these pins can be either cemented in position into an oversized hole. Some pins are made which screw into position. These particular ones are friction grip pins. And an undersized hole, about 1/1000th of an inch smaller in diameter than the pin, is drilled with a small twist drill. These pins are then pushed into position. They have annular barbs running round them, a very small dimension, which prevents them from coming out once they're pushed into position. It's obviously critical that the position of these pins should not be close to the pulp, nor should it be too close to the outside, lest it break through into the periodontium. They are cut to a depth of 1.5 to 2.5 millimeters according to location. The pins are pushed in position, and in the molar preparation here we've got 1, 2, 3, 4, 5, 6 pins. In a smaller tooth, a smaller number of pins would be used. These are placed in at different angles because that also gives a mechanical lock. They don't all have the same angle of draw, so it gives a little more security. The upper ends of the pins may be bent over or pushed in different directions if it seems suitable in a particular case. This is done clinically in the mouth, of course, under local anesthesia. When these pins are placed in position, a copper band is adapted around this to form a matrix. It's carefully contoured to the soft tissue relations of the cable surface angle here. Is put in position, it's trimmed so that it clears the occlusion, and then amalgam is condensed into here just in the same way you would do for a normal amalgam restoration. And the occlusion is checked to make sure that it's quite clear. The copper band matrix is left in position for 24 hours whilst the amalgam hardens, and then when the patient returns, the copper band is taken off and the complete crown preparation is cut in the amalgam and any remaining tooth substance which may be available. It's customary, wherever possible, to carry the preparation, of course, onto tooth substance so that the amalgam is completely covered. And you saw earlier on the preparation that had been cut into amalgam placed in this situation. So 3 types of pins that can be used then. Those in which you drill a slightly oversized hole and cement a pin in position. Those in which the pin is screwed into a pre-prepared hole. And these particular ones where the pin is pushed into a slightly undersized hole and is held in place by the resilience, the elasticity of the dentine. Now, other types of material are used to form a core than amalgam. And we have here another model showing a bicuspid tooth. A vital bicuspid tooth in which most of the coronal surface has been destroyed. There's perhaps a little bit more left here on the buccal surface than there was in the other preparation. You make use of anything which may remain. And this one has 1, 2, 3, 4, 5 of the friction pins which are pushed into pre-drilled, slightly undersized hole. Now, in recent years, with the development of the composite resins, which have very high compressive strength, use has been made of those in building up the core. Such a core would be built up in exactly the same manner as for amalgam, although it's not always necessary it's not necessary, of course, to leave the matrix on for so long a period of time, and once the composite resin is set, the preparation can be completed perhaps in one visit. This is not actually a composite resin. You'll recognize it as Duralay, which is used just to illustrate the situation here because of the color difference and the ability to contrast well with the tooth and show easily on the screen. This core has been built up, would have been built up in composite to an approximate shape, and then is finished and cut with the usual cutting instruments. Notice that this has got a shoulder all around the preparation. It's intended to receive a complete crown, a veneer crown in a maxillary bicuspid, and as made with a shoulder all around with a bevel to that shoulder. So you see here then the use of the composite resin as forming a core built on pins on a vital tooth. Let's return now to the first model just to summarize the amalgam core crown. A restoration which can be used as a bridge retainer on a vital tooth anywhere in the mouth in which most of the coronal tissue has been lost for some reason or another. The amalgam core crown can be restored with a complete crown of any type, either a veneer crown as is seen here, or an all-gold cast crown, or any other type of crown which is desired. The amalgam core crown then, amalgam pin retained on a vital tooth. Just to summarize the total presentation now, we go back to this diagram which you saw at the beginning. Bridge retainers used, 3/4 crown used both anteriorly and posteriorly. The veneer crown, which is used again on both anterior and posterior teeth. This is the crown with the aesthetic facing, used where aesthetics are important. The core post crown, used on a non-vital tooth as a means of placing a complete crown. The cast crown, used on extensively destroyed teeth where aesthetics are not critical. The amalgam core crown, a means of restoring a broken down vital tooth and placing on it a complete crown. The MOD inlay, used in posterior teeth where previous restorations have cut into the central part of the crown, and this is the most conservative method of restoring what remains. The pin ledge restoration, used on anterior teeth as an aesthetic retainer, leaving the labial surfaces untouched. In this presentation, no attempt has been made to describe the individual preparations and techniques for each of these particular retainers. This has just been a survey of all of the retainers used in bridge work and some indication of their application.
You've been listening to a presentation from the University of Michigan School of Dentistry, which is dedicated to supporting open learning and open educational resources. This recording is licensed under the Creative Commons. It may be reused and redistributed for nonprofit use. Please attribute materials to the University of Michigan School of Dentistry and redistribute under this same license. For more information on how this and other University of Michigan School of Dentistry recordings may be used, visit www.dent.umich.edu/license.